Okay, so this is a 2016 mock exam question on perspective. Let's have a quick look through it. So many people enjoy skateboarding as a recreational and competitive activity. The image shows the typical skateboard ramp, as you can see here. B2 shows the elevation and plan of the ramp. Draw the plan and make a perspective drawing of the structure given the following information. So the spectator is 2.4 meters away from here. It's at a 30-degree angle, as we can see. The picture plane is touching corner A, so I know the picture plane touches that corner, and horizon line is only 700 millimeters above ground. You can see it's at scale of 1 to 20, so the first thing I'm going to do is I'm going to work out all my measurements. So I'm just going to do one, and then I'll pause the video and do the rest. So if I get my pen, so 600. We want to divide that by 20. Divide by 20. So that will go 30. So that 600 becomes a 30 millimeter tall part of our drawing. Okay, I'm going to do the rest and then I'll be back in a second. Okay, so now I've worked out all my measurements here. They're all in millimeters. Oh, actually I forgot to do one. I forgot to do the 2.4. So I'll just do that really quickly again. Okay, so now we have all our measurements. I'm actually going to start my drawing. So you can see here I have my page landscape. Usually you would have this portrait, but I don't have enough room here where the camera is. So I'm going to try it landscape, hopefully it works out. I'm going to come in roughly 50 millimeters from the side of, well actually I'm going to come in 50 millimeters roughly, and I'm going to work out how far I'm going to need down here. So I'm just going to do a quick sketch here for myself to figure out where to start, and then I'll tell you where to start. Okay, so I've just done a quick little calculation just for myself, and I'm thinking that I should put my spectator, just because I've put this portrait, I just want to maximize the amount of space I'm going to have. So I'm going to put my spectator just here, so roughly up 10 and in 10 from the bottom corner. So that's going to be my point S. Again, put your page on portrait if you're doing it the normal way. Yeah, that should be enough room. Just going to double check something again. Okay, yeah, so just reviewing that, I'm actually not going to do that. I'm going to bring my spectator in a bit more. So I'm going to start in. Again, you won't have to worry about this in your exam. Usually you'll be given the page, you'll have enough room to put your page in portrait, whereas I'm just trying to maximize the height I have here. Maybe this will work out fine anyway. So I'm just going to come in roughly 60 millimeters. I'm going to put my spectator there, and it's roughly up about 20. That'll do fine. And we're shown in the question now. I'm going to leave that there if you want to take a screen grab. So I'm going to come up now at 30 degrees, and I'm going to start drawing my plan. I'll do the first few lines, and then I'll pause it and come back. So I'm going to switch over to a pencil. And I'll try and draw heavy enough for you to see. So I know my corner of my object is 120 millimeters from there. So that's 100, that's 20. So now I have one corner of my object, or my plan. So basically I'm going to just come across, up, and draw the outline here now. I'll be back in a second when I have that done. So I have all my measurements. I know 1000 is 50, so I'm going to come over 50, up 110, back across, down, and you get the idea. Okay, so there we go. You'll see the measurements for these 2 points here to get in here are shown in the elevation. So they're both shown at 300 millimeters at full scale, or 15 millimeters to our scale of 1 to 20. Okay, so now that we have that, we need to find our cone of vision. So I'm going to get rid of my T-square for a minute, and I'm going to get my fine liners. There we go. So I want to draw my cone of vision, which is the two most kind of widest parts of your object or your plan back to your spectator. So that would be from this point here, because it's the furthest to the left, and we're going to bring that to the point on the right, and then we'll bisect that angle and find our line of vision. So bisecting our angle using our compass. Swing any arc that cross both legs. Step your compass up, swing again, don't change the radius, and swing again. And there you will have now your line of vision, or your line of sight. Okay. That's just showing that both of those angles are the same. To find our picture plane, we're going to go perpendicular to that line of vision. I'll just switch over to blue. So I'm now going to draw my picture plane. Which extends through point A, as we were told in the question. PP. To find your vanishing points, we just need to come parallel to the external edges of our shape. So we're going to come horizontally here and vertically here, or parallel to this edge, depending on how you've set your page up. Because I have it set up like this, I can project over from S parallel to this bottom edge, and I can find my VP1, and to find the other I'll just come up vertically, which is parallel to this edge here, and I found VP2. The next thing I need to do is need to decide where I'm going to put my ground line. Your ground line is always parallel to your picture plane, so let's set that up over here somewhere, and then we need to use the dimensions we were given to set up our horizon line. So using sliding set squares here, I'm going to set up our ground line. I'm just going to draw this in pencil for now. And I'll extend its length just for now. The next thing I want to do is I want to measure perpendicular to that, which will actually be along this line of sight. So if we extend that along, that will be perpendicular, or it should be perpendicular. And I want to measure up to get my horizon line. So this is our ground line, GL, and the height for our horizon line was 700 millimeters. So 700 divided by 20. So 20 goes into 73 times. Leaves 10. 35. 30. No, it goes in 0. I'm having a little bit of a math crisis. 700 divided by 20 is 35. Yeah, I wasn't. Sorry, I don't know what happened there. Just getting late. Right, 35. So that's how high up our horizon line is. If you have a calculator, use it. Saves time. So there's a point on our horizon line. Project up so that it's parallel to your ground line and perpendicular to your line of sight. And then get your vanishing points by projecting them up parallel to your line of sight to sit on your horizon line. If I use my parallel set squares, project up that height, I've now got VP2 and VP1 just here. and I can start constructing my my perspective. So we've got corner A just here. That touches the picture plane, so we can find that immediately. To find it, we need to project it parallel to our line of sight up onto our ground line, and we now have point A. So there's point A in our perspective. We now have to measure all our heights along this line, because this is the only line that we see as a true height. It's the only place we can see our true heights. So we need to use now our measurements from here to find our heights. So I can see that this corner here is only this height, but I don't have that height. It looks to be 15 from what I can see here, so I'm going to measure up the right height. I'm assuming that it's the same height. Yeah, it looks about halfway across there. This isn't the technical way of doing it, but I'm guessing they just forgot to put in a measurement there. So that there is 15 millimeters when it's scaled, so I can measure up along here 15, and because it's a corner, it's going to be a solid line, and I can vanish both top and bottom of that to both vanishing points. Now I'm going to recommend just staying with this part here for now. So I'm going to find this corner next, which crosses the picture plane here at this point. So I'm going to project that up. From where it touches the picture plane. And because that's on this line here, that vanishes, it will be on this line here that vanishes. So it's going to be right there, and we now have the back edge as well. Because I have this corner now, this will vanish to this vanishing point, so I can join her back to here as a light line for now. And I'm actually going to find this corner here now. I already have it there. I already have it projected up. I actually have it right there. I can draw that in a vertical line. There we go. So now I've got this part here finished. I'm going to work my way over to here now. I can see that this edge will not vanish because it comes down, but the one on the ground will. So the bottom edge of this will vanish. So this edge will join to this vanishing point, but come forward like that. Now this, by right, should not cross the ground line. It should stop somewhere here. So if we've done it right, it should appear as such. So I'm going to join back. I'm going to find my point of intersection on the ground, or on the picture plane, and I'll project it up. And it does not pass. And now I have the bottom edge of that ramp, and I can join back to find the top edge. I could use a vanishing point there, but because I don't have the degrees, I don't need to. So I can start finishing off parts of this now. And actually, looking at this, I think I've done parts of this wrong, because if this is a ramp, then this here will be a ramp also, just looking at the picture. So this edge here should actually be flat, which means that this height here is not needed to be drawn. So I'm just going to fix that. If I can find the rubber. So hopefully this one makes sense now. Get that out. So this here will also be inclined like this, as you will see in the picture of the question. So now I'm vanishing that point, which will be from here, vanished, and I'm able to find this point, which will join back to here, which is, so I have this point, which is there. This point will be along this line that I just vanished. So if I join it back to S, my spectator, find where it cuts the picture plane, and it does intersect where both heights are, because I had previously done it, so I can join it back, and you can see the ramp starting to form. I can now vanish this point. I can find this here, it's on the ground, by projecting up parallel to my line of sight. Point on the ground, join it back, and if I want to find, which point now will I want to find? I want to find this back edge, which will be inclined. So I need to find this small portion here. I basically need to extend this and find an imaginary point here. So I'm going to find this point. It's going to be at the same height as this point, so it's going to be at an altitude of 15, and that will give me my line, but it won't be a full solid line because this point in theory doesn't actually exist. So join it back, project it up, somewhere along there, but I know it's at this height, so that has to be it. I can join that to there, and all I wanted was to get that little section just there. So now that I have that, I also have this line here which I will need to draw in once I have this point here. So now I can find that point, project it up, and draw that line in now solid, and I can vanish that back. Oh, I shouldn't have done that. Never mind. Don't vanish that back just yet. Vanish that back as a construction line for now. Next thing I want to find is I want to find this edge here, so this face, which will be this height here, so it's going to be at a height of 600. So I need to be able to now transfer that height. So I'm going to first off find the 2 points that are going to be on the surface. So the very back point I can find, definitely, because I know it's on that line. So find that point, which will cross there. So that will be it there. To find the other point that is forward of it, I'm going to vanish that forward and then join this back, find where it cuts and project up, which gives me this point. So now I have that edge here. I just need to now find a way of getting my 600mm height, which is actually 30. So I'm going to actually step that off on my true length, or I can extend this across to touch the picture plane. I can then bring that up and I can measure my true height along there, because this point now touches my picture plane. It doesn't need to be joined back to spectator. Project it up, measure up my 30mm, and vanish that back to VP1. And then extend this up to hit that vanishing line, which is which one? there and there. Bring that up and join it back. So now I've got that first front edge. This here can join to here. I'm going to find the inclined surface. So because it's at a 15-degree slope, we need to use vanishing points. This is all vanishing this way, which in my drawing is vanishing to VP1. So we need to add a 15-degree incline to this vanishing point. So we're going to use our protractor. I'm going to measure 15 degrees forward. I'm going to extend that from S, and if I come perpendicular from where the VP cuts the picture plane, I will get a height that I can then step above my VP1, which will give me the correct vanishing angle. So I now have that height that I want. I'll call it H1. And if I step that off above my other vanishing point, taking that height, step it off above my VP1, that will be an auxiliary vanishing point number 1, and that will give me a vanishing point for both of these inclined surfaces, like that. And all I need to do now is find these 2 points and project them up. So as normal, join it back, find where it cuts here and bring it up parallel using your sliding set squares. And I found the first point. I don't need to find the second because I can just vanish back here. And I found the top surface of the inclined edge. You can drop that down vertically. Like so. And there is our auxiliary finished. So hopefully you can see how I got my vanishing point. So this here will be H1. To get this point, I had to vanish a line going that way, which was this imaginary line here. So I had to imagine I actually had that point. Hopefully this has helped. And obviously if you had surfaces vanishing the other way, or you knew the angles of these surfaces, these ramps, you would be able to create vanishing points above both vanishing points for these. So if this was a 15-degree slope, and it might be, I don't know, it's fairly close, so that could be an 15-degree slope. It's just inaccuracies on my part, I don't know, but in this case we didn't need to use the auxiliary vanishing point for that question. Let's just double check we've answered everything. So using auxiliary vanishing points where appropriate. Yet we weren't given this incline here, so we didn't know. It was quite hard to tell the shape of this, but in a normal question usually you would get a lot better pictorial image of what the shape would actually look like. Yeah, if you have any questions, let me know.